GATE 2022 Metallurgical Engineering Question 45. A non-rotating solid spherical object is fixed in a stream of an inviscid incompressible fluid of density ρ. The flow is horizontal, slow, steady and fully developed far from the object as shown by the streamline arrows near point O. Which of the following statement is or are true? It should be noted that B represents the center of the sphere and the straight line, horizontal line OAB intersects the surface of the sphere at point A. So there are four options and we need to identify that which of the four options are correct. So as in the image, it can be seen that the streamlines, when they are moving towards the sphere, they are deflected by the stationary sphere, and since it is given that the sphere is smooth in surface, so we can ignore the frictional effects, and also it is given that the fluid is incompressible and inviscid. By inviscid I mean the viscous effects can be neglected. So, and incompressible means there is no change in density with pressure. So it is incompressible fluid and inviscid, and the solid sphere is smooth and sphere is not rotating. Now under these conditions, the streamline OA, the point A will represent the stagnation point. It represents the stagnation point. Why it is called as stagnation point? Because this is the point at which the fluid is brought to rest. Because in incompressible flow, the fluid will deaccelerate near isentropically from its free stream velocity to zero at the stagnation point. And the pressure at the stagnation point is known as stagnation pressure. Okay, so pressure at point A is stagnation pressure. You can also represent it by PS. So the statement A, the velocity of fluid at point A is 0, is correct. Also, what is the pressure difference between point A and point O? Since it is an incompressible and steady flow, it is given that it is a steady flow, fully developed. So we can apply Bernoulli's theorem between point O and A. So applying Bernoulli's theorem between point O and A, we will get pressure at point O by rho g, velocity at point O square by 2g, plus datum head or potential head at point O. It should be equal to pressure at point A by rho g, velocity at point A square by 2g, and ZA. So applying Bernoulli's theorem between point O and A, we will get pressure at point O upon rho g, velocity at point O upon 2g, datum head at point O. It should be equal to pressure at point A upon rho g, velocity at point A square by 2g, and ZA. Now since it is a horizontal line, so we can cancel ZO by ZA because they both are equal on a horizontal line. Also, we know that point A represents the stagnation point, so velocity at stagnation point is 0. So this factor will become also 0. Also, it is an incompressible fluid. so it has no effect of the pressure. Pressure won't have any effect on density. So density at point O and density at point A will also be equal. Since G is common both sides, so we can since G is common on both sides, so we can cancel G on the both sides. And what we are left with is V square by 2 is nothing but PA minus P naught upon rho. PA minus PO upon rho. Or rho V naught square by 2 is the pressure difference between point A and point O. Okay. From Bernoulli's theorem, we have deduced this. So if you look at option B, the fluid pressure at point A exceeds that at point O by an amount of rho V square by 2, where V represents the fluid velocity at point O. So we have just proved it. So this point is also correct. Let us look at the option C. The fluid moving precisely along OA will turn perpendicular to OA and circumvent the object. That is not true, because the fluid that is moving precisely on OA is going to come to rest at point O. Point O represents the stagnation point, and all the kinetic energy is going to convert to pressure energy. Okay, and that is equal to the stagnation pressure. So this option is false. Let us look at option D. On each side of the central streamline OA, the flow will be deflected round the object. So as we can see in the image also, all the streamlines that are in neighbor of OA are going to get deflected around the object. So option D is also correct. So only option C is false. Option A, B and D are true.